Okay, let's take fractions a step further now with lesson 23 and talk about complex fractions. These really just look hard, but they're not. A complex fraction is a fraction over a fraction. In other words, it's a fraction in the numerator and a fraction in the denominator. Or it could be a whole number in the numerator and a fraction in the denominator, or vice versa. But anyway, we're dealing with multiple sets of fractions. Remember, any fraction is just a division problem. So, for complex fractions, we start off by writing it as a division problem. In other words, you take the numerator, which is 1/8, and you say divided by the denominator here, which is 3/4. Now you know what to do. We have to take the first fraction and leave it alone, and take the multiplication, change it to multiplication by the reciprocal of the second fraction. Cross-reducing, we've done all this before, and multiply numerator times numerator, and denominator times denominator. Complex fractions simplify very nicely. Usually it's not a problem. Let's do number 2. I have 5/12, and it's divided by the other fraction, which is the denominator, 15/12. Well, what is that? That's really 5/12 times 12 over 15. Well, the 12s will cancel or reduce. 5 is going to be reducing with 15. My answer, 1 times 1 in the numerator, 3 times 1 in the denominator. It is 1/3. You should probably stop now and see if you can work the other 4 problems and then check back and see how you did. For number 3, we say 2x over 27 divided by 4 over 9. Now let's change it to multiplication. 2x, I'll write it over here, over 27 times 9 over 4. And let's reduce. 2x, that's going to be just plain x, or 1x. 2 divides into both that and 4. And 27 and 9 can both be divided by 9. In my numerator, I have x times 1, which is x. In my denominator, I have 3 times 2, which is 6. If you want to write 1x up there, that's okay, but in later algebra, you're never going to see a coefficient if the coefficient is 1. Number 4, I have 5a over 24 divided by 1 over 12. Let's take and flip that to 5a over 24 times 12 over 1. Now let's see if we can cross-reduce anything. 24 and 12 look like they're going to reduce. And I say 5a times 1 is 5a, and 1 times 2 is 2. It's an improper fraction, but that's perfectly okay. If the problem begins as a fraction, even if it's improper, we can always leave it that way. Problem number 5 is 7/10 divided by 14z over 25, which is the same as 7/10 times 25 over 14z. Let's reduce, cross-reduce where we can, divide both 10 and 25 by 5, and divide both 7 and 14z by 7. Now, multiplying numerators, 1 times 5 and 2 times 2z gives us our answer. Problem 6, I've got 3y over 11 divided by 1 over 2, which is, of course, 3y over 11 times 2 over 1. Nothing reduces or cross-reduces, so we multiply numerators and we multiply denominators, and 6y over 11 is our answer.